Hey, Miss Sparks.
Hey, Adriana. Sorry this has been so complicated. I had two very long marathon math labs
No,
today.
you're
I
fine. Don't worry about it.
started at 1 o'clock this afternoon, and I think I finished at 4:30 and had to put dinner on for my family because they would be very unhappy with me if I didn't cook them dinner.
Yeah, of course, you're fine. Don't worry about it.
Okay, Angel. And I know I started praying for you the minute that I knew you had to stop one thing and go to another because I know that we're the same person. So I know what that feels like and I know what type of anxiety that probably put on you. So God bless your heart. And I just prayed that the Lord would just give you extra whatever you needed to get everything done.
Thank you. Yeah, my coach had practice scheduled and then canceled it, and then like the moment that I hit send for the email that said it was canceled to you, he scheduled it again, and I was like, So I have that, but I might just, depending on how this is going, I might just text him that I'm going to be late because, yeah, I need to.
Okay. Well, I tell you what. Let's do a couple of things because I'm seeing that it's graphing. Most of it is graphing rational functions, correct?
For a few pages, yes, and then it isn't anymore. So I don't really know what's going on there.
Oh, okay. All right.
But
Well, I need to take a look at those. But I had this thing that I'm going to share with you, and I know that I passed it out last year, but it's called the 8 legendary steps in graphing rational functions. Do you remember that handout that I gave you?
Vaguely, I remember the name.
Okay. Well, anyway, it's for me, and I've kind of got it pulled up over on my other computer. So I think maybe I'll go ahead and pull it up here so that I'm sharing my secrets with you.
Mm-hmm.
And then we'll start working. But I say this, I know that you probably oh, come on, computer. I need you to work a little quicker than this for Adriana and I right now. Okay, well, it's not gonna, whether I want it to or I don't. Okay, here we go. So I will kind of want to go over these with you. And if she hasn't said this, which I'm sure that she has, factor but don't cancel and find the domain. The domain is all real numbers except whatever makes the denominator 0. Okay. That's going to be the very first thing you're going to do all the time.
Okay.
Okay. And then simplify. Use this simplified result from this point on. Cancel if you can, but don't forget the restrictions. And we're going to probably get to one of those. And I'm going to share this document with you so you can print it out. You want me to go ahead and share it with you so that you can print it out and have it next to you?
Sure.
Okay. How do I share? Share. Look. Do you care which Adriana that it goes to?
No, go for it.
Okay.
I think either way it'll come to me, so we're good.
Okay. So we're going to kind of follow these steps through here as we do these. So like you've got this first one, the 2x plus 3, like if you would, and then the x minus 3. So on this particular one, your vertical asymptote is always what would make the denominator 0. Are you feel pretty clear on that one?
Kind of.
Okay.
I just kind of winged that one. I have no clue if it's right or wrong.
Okay. Finding the zeros of the denominator is always the vertical asymptote. If you think about it,
because you always set it equal to 0, correct?
Yes.
Okay.
I guess I always think about it. The H, the horizontal asymptote, has to do with when you're taking the ratio of the numerator and the denominator. Okay. And so I always think, okay, well, the numerator is involved with H. So so it, H comes before V in the alphabet, right?
Okay.
It's
Uh-huh.
H is the ratio of the numerator and denominator, but the V, the vertical asymptote, is always the denominator, and V comes after H.
Okay, that makes sense.
Okay, that's how I try to make that connection, and hopefully that'll help. I don't want you to think that H has to do with just the numerator, but
No, I understand.
okay, good. All right, so that's hopefully that'll solidify the vertical asymptote for you. It always is around the denominator.
Okay.
Okay, and it's whatever would make the denominator 0. Okay.
Mm-hmm.
Um, I'm trying to think. What is the slant? This is slant asymptote, right?
Yes.
Okay. All right. Cool.
All right.
I just was trying to remember. Okay. So the vertical asymptote x equals 3. That's perfect for that, because that's what would make this denominator 0. So let's kind of move on based on that. Let's move down here for just a second. Let's look at the denominator here. So you're going to want to factor that. You want to factor the top and factor the bottom. And the top, you can factor out a 10.
Okay.
And the bottom, you're going to get this. And so if you remember on our 8 legendary steps, the very first thing is factor. And remember how last year in class, y'all got really annoyed after I would walk around the room and just say factor, factor, factor. That's always what you're going to do first.
Okay.
Okay. And then what you're going to do is your domain and range. You're going to figure this out. Your domain is going to be all real numbers except wherever that denominator equals 0. All right. So the denominator is going to equal 0 at -4 and -2.
Okay.
And so I don't know. This is how I would write it. I don't know. Is she strict about how you write it?
I really don't know.
This is how I do it. That's my fancy R for all real numbers.
I'll check with her tomorrow to see if she takes that, but for now, I'm just going to roll with that.
Okay. And if not, I don't know. If she does bracketed, it would be this except for this. But you can't have these.
Yeah, she gave us in class Wednesday 2 packets, and I just sent you part of each packet. But she sent 2, and they're both due tomorrow, and I have no clue what's happening.
Oh,
so, yeah.
Bless your heart. Okay.
And I still have a ton of lit work to do that's due tomorrow too. So.
Oh, yay! Oh,
yeah.
All right. Well, we'll see what we can knock out. So we got 1, 2, 3, 4. And is she going to let you use your graphing calculators for these?
No? I would assume so, yes. She isn't very strict about that.
She is not very strict?
She's not.
Okay. Because I was going to say, that's definitely going to help you. You know what I mean?
Mm-hmm.
All right.
Well, she also knows that I struggle a lot with her class, so she should be pretty lenient.
Now, I probably should. I actually shouldn't be drawing these first because.
Oh, wait. Is it positive or -2 and 4?
You're right. It's probably, Lord, it's a -4 and -2. And one of these is going to be a whole and not an asymptote. Because when you start to cancel like that, it becomes a hole in the graph. Did you go over that?
A little, yes, but I still am not very clear on how that works.
Okay. My graphing calculator died, so I'm trying to actually type this into Desmos. So you might want to graph this.
Just the whole thing.
Yeah, so we can talk about it. You know what I mean?
Uh-huh.
Just graph it as is. Oops. Sorry.
Oh, you're good.
10x. Because that way
but
we
it
can
looks.
talk about it. I'm sorry?
I said I got it graphed, but it looks weird.
It does look weird.
Yeah, it's like just a line.
Did you put things in parentheses? Like the top in parentheses? Like
Maybe
10x plus 20?
I don't think so. Let's see.
And then the bottom in parentheses?
Okay.
That might change it a wee bit.
Mine. Uh-huh.
Did it?
Well, we'll see. I accidentally deleted everything because I'm a literal grandma when it comes to calculators or any technology.
I understand perfectly. You really have no idea.
Oh, there we go. Got it.
Okay.
1 sec. Let me ask my mom something.
You're fine.
Okay, sorry. I just have to text my coach because I'll just be a little late to practice.
Well, I was going to say, whatever you need to do.
Well, that's probably just smarter for me because this is like our season's over. This is just a like end of the year practice, so I can be late to it.
Okay. There should be a hole in the graph at x equals -2. Does it show a little hole for you? Mine does not on Desmos, and that's why I'm asking. And there really should.
It's not showing me one at -2.
Mine keeps skipping to. Oh.
But then again, I really remember what a hole even looks like. So they're all good questions. I don't think it does. Let me double check. I have like so many worksheets.
Yeah, mine does. It actually says undefined. So there should be a hole there. And when you draw your line, because you've got the x intercept.
Yeah, mine isn't just one line though.
Right, it should be two with the vertical asymptote of x equals -4.
Yeah.
1, 2, 3, 4. Right?
Yes, ma'am. That's what it looks like.
And then you'll have your thing that goes like that. And then your x-intercept is 0 and 2.5. Well, or y-intercept is 2.5.
Wait.
Because if you plug in a 0 for x, you're going to end up with 20 over 8, which is 2.5. 1, 2.
Wait, then what's our horizontal asymptote then?
The horizontal asymptote is going to be the ratio when, if the degree of the numerator is less than the degree of the denominator, the horizontal asymptote is y equals 0. So the numerator is less than the denominator. And in fact, it is in this case. Because the numerator has a degree of 10x to the first, and the denominator is x squared. So the degree in the numerator is smaller than the degree in the denominator. Thereby, the horizontal asymptote is y equals 0.
Okay.
So that's why it's running along through here. And my graph is going to look really ugly, and I'm sorry.
No, you're fine. How'd you get the y-intercept?
Plug in 0 for x.
Okay.
So if I do that, that leaves me 20 over 8, which reduces to 2.5. Let's see. Wow, my graph is so ugly. On there, I was looking at it, I was like, oh. And then y, to me, looks like it's going to be all real numbers. Well, no. Because we've got a short to 0. And 0 wouldn't be. A holes are 2. And there's no slant asymptote.
It's a +2 or a -2?
-2. You were right.
And why is there no slant? I just don't understand how any of it works. So.
Okay. And that's on that sheet too. Mm-hmm. So if the degree of the numerator is greater than the degree of the denominator, mm-hmm. then it says there is no horizontal asymptote unless it's a 1 degree difference, like number 3. There'll be a slant asymptote there.
Okay.
Okay, so if the degree of the numerator is greater than the degree of the denominator, which in case number 3, that is true, there is no horizontal asymptote, except for when the degree differential is 1, and then there's a slant asymptote. And that's when you have to do long division.
Okay.
And the slant asymptote is the quotient or the answer of the division problem minus the remainder. Yay, right?
Yay. I'm just trying to understand.
Yes, I got you. Okay. Did you get that piece of paper?
I did. Yes.
Okay. I was going to say, do you, and this graph would not cross the x-axis. There isn't an x intercept. I wish I knew how she wanted you to write the domain and range.
Yeah.
You know?
I don't really know. She doesn't give us very much direction. So.
Let me change that to -2. That, because that would help, you know, if I knew that. Because I don't want to teach you one way and then it be, because I see that you used bracketing up above.
Yeah, that's usually how she does it, but I don't know how strict she is about it.
Okay.
But like, I haven't seen her do it any way other than bracketing. But she never told us that we have to bracket. So,
Okay.
you know.
Because the range on this one is like essentially what it looks like is you've got negative infinity to 0 unioned, but in 0 would not be included, but it's unioned with 0 to positive infinity. But I don't know how she would want that to be because 0 is not
She would write it.
Huh?
That's how she writes unions.
Really?
Uh-huh.
Okay. All right. Well,
when we do number 3, can you like walk me through each step of finding each thing in the little like columns, you know?
yes.
Okay, awesome. Because I'm still like kind of lost.
Okay. Well, and that's what I was I was actually trying to go through that steps so that, but then I saw that I was trying to go through those steps of graphing it. And so maybe what we'll do is just sketch the graph and then go back to domain and range last.
Yeah, when we did it in class, she got the X and Y intercepts first, then graphed it, and then we kind of figured everything else out from there.
Oh, she figured the X and Y intercepts first?
Yes.
Did she have ones that there was no X intercept?
Honestly, not 100%. She doesn't do very many examples in class. She'll do like 2 or 3 and then leave us to do the rest. So, since it's an honors class, I guess.
Oh, yeah, that's probably it.
Yeah, we love that.
Okay. All right. Well, I'm I'm just double checking something real quick. So actually, why don't you go ahead? I know that you can tell me what the vertical asymptote is on this one. So you could fill that one out.
Yeah.
Right?
Yes, it's just 2, right?
Uh-huh.
Okay.
Yeah, there is definitely not an x-intercept on that one. I just worked it out. On number 2, there's not.
Yeah. That makes sense.
Okay, and then this is going to be x minus 4 and x minus 3. I just always like to factor when I can to make sure that there's not going to be anything canceled out. That's the primary reason that you want to do. That's why you always want to factor first, because your first step is factor, don't cancel. And then it says that you can go ahead and claim your domain from there. on this very first step. That was the only reason I was filling it in, because it's going to be all real numbers except for where it doesn't equal 0. So I don't know if that throws, or for where it with the denominator equals 0. So that's going to be x can't equal 2. But so we won't mess with the range till we get all done. Now the x-intercept.
How would you write the domain like bracketed though? Is there a way to do that?
Yeah, I guess you could actually do it like this, the same way.
Can you not write it with
all real numbers. I'm sorry?
Is there not a union for it? Is that not?
Because it's going to be all real numbers except for 2.
Okay.
Unless she did it like this. Did she do it like this?
Yep, that's what she did.
With a union in the middle? My bad. Not okay.
Maybe.
Okay. There would have been a union, maybe a union in the middle.
Yeah, that's what I was thinking.
All right. See, I typically do all real numbers except for 2. Okay. But that doesn't, but I want to.
Yeah, that's why Google Hangouts is like a little tricky, because since you're not teaching me this year, you don't know exactly how we're doing it.
Yeah.
Yeah.
But I'll if I can I'll try and get some of her worksheets worked out, from her, and I'll see how she does it and try to work it that way. You know what I mean? Or any examples that she ever has, if you write those down, that will help.
Okay.
All right. So, now on this one, the second step, it's a simplify, but there's nothing to simplify. And then the next one is to find intercepts is the next thing to do. So what we'll do is we're going to plug in 0 for x to find the y. Okay, so if I plug in a 0 for x everywhere there's an x, here, 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 that's basically going to give me a 12 over -2. Do you agree?
Yes.
Okay. So the y-intercept is this. So, I probably should have made that black, actually, so my line can be pink.
There we go. Yeah, it's a little tricky to see.
That's better, isn't it?
Definitely. Yeah, okay. The line is like not any thicker than the others, so.
I know, it's hard, isn't it?
Yeah, it's a little tricky.
Oh, this is a graph, girl.
Are you working out the x-intercept or?
Yeah.
Oh, okay.
I'm looking at the x-intercepts. They're going to be fun. And we got our y-intercept. Okay, so the x-intercepts, we're going to plug in a 0. And then you've got x minus 4, x minus 3, all over x minus 2. And so what we have to do now is multiply both sides by x minus 2 to get rid of the x minus 2. Does that make sense to you?
Yes.
Okay, because I'm trying not to skip steps, but if I did that, I'm going to eliminate it from this side by doing this, right?
Right.
That's going to go away. And then when I multiply anything by 0, it's always 0. So I wasn't going to show it over there because I don't have a lot of room. So I was trying not to be, I was like, I don't want her to think, oh, she's skipping steps. So that gives me 2 x-intercepts.
Oh, okay, yeah. So it's 4 and 3. So it's
Yes.
4 comma 3 and
One.
then
Well, yeah. Sorry
I mean
about
4
that.
comma
It
0.
should look like this.
Yeah.
It should look like 4 and 3, like that. Okay.
Yes.
So 1, 2, 3, and then 4. Cute. What kind of graph is this?
It's gonna be really
Okay.
it's
And then the vertical asymptote is going to be x equals 2.
mm-hmm.
All right. And the horizontal asymptote, I'm going to erase this. Are we good so
Mm-hmm.
far? Okay. And you're understanding where we're getting everything so far?
Yes, ma'am.
Okay, good. Oh, great. I just erased my line. I just erased my x-axis. Um,
Oh no.
I know. And then what we've got, okay, so what we've done on the legendary steps, we found the vertical asymptote. We found our intercepts. That's step 3. We found our vertical asymptotes. So now we're at the horizontal asymptote. And we've got 3 rules or tests that we run them through. And this actually fits into category 3 or C on that sheet. If the degree of the numerator is greater than the degree of the denominator, then there is no horizontal asymptote. However, if the degree of the numerator is 1 degree more than the degree of the denominator, there's an oblique asymptote, and then you have to do long division. Now, let me ask you this. Are you a synthetic divider or are you a full long polynomial divider?
Probably synthetic.
Okay. So that being the case, then you're going to want to go 2. And then we've
2
got a 1.
because it's the vertical asymptote.
Well, we're just going to divide it,
Oh, okay.
you know,
Um, yes.
because this is a division problem itself.
Yes, I understand now.
Oh, okay. We're actually doing what it's telling us to do to begin with. How? It's like, okay. You were trying to avoid that, but now we have to.
Yeah,
Okay, 1 times 2 is 2, and then -7 minus 2, that's going to be -5, and -5 times 2 is 10. Yes, -10. So that's going to give us a remainder, but we're supposed to ignore the remainder. Did she talk about this in class?
very vaguely I remember that, but yes, I know she definitely did. We just kind of like touched base.
Okay. So this is going to be y equals 0. Or no, I mean, I'm sorry, my bad. This is none. Help me, Lord Jesus. This is none. Because typically, when you have a none in the HA, there will be a possibility of having one in the SA. But
Right.
if you have something in the HA, you won't have anything in the SA.
Okay, that makes sense. That's helpful.
Okay. So the slant asymptote, or oblique, as they're sometimes called, is 5. So y equals 5.
Okay. Then and then would we draw it as we would a horizontal asymptote?
Wait a minute. I guess, but when I'm looking at the graph, it looks like it's a -5.
Hmm.
So I'm confused. And I know that doesn't help you much if I'm confused.
It's okay. It happens.
Did you graph it?
I'm working on that right now. 1 sec. Yes, it's graphing.
Okay.
No, mine appears to be. Wait.
At -5 or +5?
I honestly don't even know what a slant really looks like, so I have no clue. I think +5.
Maybe
Is it graphed?
Like they
Horizontal?
look like check marks.
Yeah, I don't know where I'm supposed to be looking exactly.
Well, since
So,
this is a horizontal one, hang on. I was gonna show you Desmos on this computer. Since this is a horizontal one, my graph looks. I'll just try and draw it for you. My graph looks like this. There's a check mark kind of thing.
uh-huh. Yeah.
Oh my. Is that what yours looks like? So to me, the horizontal looks like it might be here. Because it certainly doesn't look like it's going to be 1, 2, 3, 4, 5 here.
Okay.
Does that make sense?
Yes.
So I'm baffled.
Maybe we should just. Oh my word! There's so many graphing problems, and I have to leave in like 20 minutes.
I will work some of them out and then send it back to you.
Are you sure?
Yep. I am positive. Is this more of the same?
That's a different worksheet, but I need that done just as badly as I need this one done.
Okay.
Yeah, I don't know why she assigned 2 full worksheets. Let's see. Let's see what all I sent you.
This. Because the others were all graphing.
Yeah, they are mostly graphing.
And these were actually finding zeros. So I'm sorry, I'm trying to this has to run through some conversion process.
Yeah, those are the pages, the like graphing pages, and then I texted you the other ones that I had to do, with an exception of one page, but I don't. Yeah. One page that I probably should send you because I have no clue what this means. Not that you have to like work it out, just for you to like kind of see. You know what I mean?
Mm-hmm.
Because I would hate to have you work everything out for me.
Well, I want to work enough that you get some examples, you know?
Yeah. I'm just more concerned about actually getting it like done for tomorrow, you know?
Okay.
And
Well,
understanding what's happening
finding
because
finding the zeros for these by factoring. How are you on that?
yeah, I have no clue how to do that. Like I know I do, but I just seem to have forgotten.
Okay. Well, you know you can take a greatest common factor out of here, which is an x. So that's going to leave you this. And then you can factor from there. So your zeros are 0, 7, and 2.
Oh, that's really helpful because I graphed it just to see, and I saw that those were the zeros, but I didn't know how. So, okay, I was trying to do something way wrong, but
okay.
Yeah, that makes sense.
All right. So this one is actually what they call quadratic form. And what that means is if the exponent on the leading term is double what the exponent is on that term, it's in quadratic form. Because see how this right here has a square and then a 1?
Yes.
It's half of that. Okay?
Okay.
So what that means is I'm half, what is the square root of 25x to the 4th?
5x squared.
Yes, good job. So, and then what is the square root of 4?
2.
I'm hoping this works. It may not work. Hang on just a second. Yes, it does. The square root of 4
is 2.
Okay, and then this is negative, so we're going to put -2 there. Now, this is that, believe it or not, this is a perfect square. Would you, because if I take, because if I write this out, right? Does that work? That didn't work the way I wanted it to. Maybe it isn't a perfect square. Oh, we're going to have even more fun, Adriana. I was hoping it was a perfect square, and it's not.
Well, what happened to the 29x squared, though?
Yeah, I'm probably, hang on just a second. I might have to slide and divide on this one. I was hoping that it was going to be a perfect square, but it's not. It would have to be a 21. So, yuck. Did slide and divide? So x to the 4th minus 29x squared plus 100. So I'm looking for two factors that multiply together to give me 100, that when I add them will give me a negative 29. So that's going to be a 25 and a 4. And then you divide each one by 25. So that's going to be x minus 1 and then 25x minus 4. Those, but except unfortunately for this, it's going to be squared. Have you ever seen slide and divide before?
You showed me earlier.
Okay. Did that help or make that matter much worse?
Well, I still am just not like 100% on what's going on. So.
Okay. Well, I'm factoring this. And this, it's tricky because this one is in quadratic form. Did you get that part?
Yeah.
About the doubling. All right. So now I'm actually factoring. And I'm using the method of slide and divide.
Okay.
And that's where I got this 100. I slid the 25 down and multiplied it by the 4. So that you slide first, and then you've got just one factor to work with. Okay.
Okay.
And then what two factors of 100 like combine together to give you a negative 29? And we That's a negative 25 and a negative 4. Well, after you slide, you then have to divide. So I have to take that 25 back out. And so I do that. And if it turns out to be pretty, I can just put that factor there. And it did. If it doesn't turn out to be pretty, you bring this in front of the x and you get 25x squared minus 4. Okay?
Okay.
You don't seem very certain.
I still I just the entire concept doesn't make sense to me. But maybe as we move on, it'll start making sense.
Well, each one of these are probably going to be unique, and that's going to be part of the problem.
Yeah, I
Like,
just don't know how on a test I'm supposed to remember each of these individual things, you know?
yeah.
Like when I'm supposed to use what, I have no idea how I'm supposed to remember that.
Well, in factoring, the thing that you're going to want to remember, like on number 1, always look for greatest common factor first. And then and then quadratic form is yet another thing, which that's what this one is. And this is a tough one to begin with, quadratic form, but it is, because then when we get down here, both of these factors are differences of squares. So they factor down even more to this.
And then the zeros would be
And then the zeros are going to be 1, -1, 2/5, right?
Mm-hmm.
And -2/5.
Okay.
So I don't know if you wrote that down and you could just kind of go back and study it later.
Yeah, I can. I wrote a good bulk of it down. I was trying to watch and absorb.
Okay. And then it looks like on number 3, it looks like you would have to come up with P over Q to find the possible zeros, like we did that one time, you and I.
Mm-hmm.
And we were lucky guesses when we were like, okay, you pick which number you want to start with, and I'll pick the sign.
Uh-huh.
That's what we would have to do here.
Okay.
So we've got P over Q, which is going to be all the factors, and thank God one of them's 1. So it's all the factors of 50, which that's going to be, 50 and 1, 25 and 2, 10 and 5, right? And I'm sure we could go on. But we can pick one of these. Which one would you like to pick?
Oh, I don't know. You can choose.
Okay. Well, I'm going to pick 2.
Okay.
And hope we're lucky.
So for each of these,
there's a different method for every single one of them, baby girl.
Oh, that's horrible.
And then there's the graphing on top of it. Yeah. I didn't pick a good one. That 2 doesn't work. Ugh. Which one? What other one should I pick? 10?
Sure.
Hey. Hang on just a minute.
Yeah, sure.
I think I have a brilliant idea. Instead of doing that, let's group. I think this is going to work. Adriana, I think it's going to work.
Oh, that sounds awesome.
It did work. Praise the Lord. I was like, surely she wouldn't do that to them.
Yeah.
This is the difference of two squares, so it's going to go down to here. So the zeros should look like this. So your zeros are going to be 5, -5, and -2. Did that one make sense? The grouping?
Yes.
Yes?
Mm-hmm. I'm just still trying to figure out how I'm supposed to remember everything on this test.
Oh. I got you, girl. Oh my heavens to Betsy, please don't die on me. Okay, a 3x squared will come out. And that's key to find because I just realized when I was getting ready to do it that a -3x squared will come out. That's the key of also knowing which thing to pull.
Mm-hmm.
And then that will come down even further. So your zeros are going to be 0, -2/3, and +2/3. The zeros here are, let's see, -5 halves, and the multiplicity is 5.
See, I don't get the effect on the graph part. She never went over like half of this in class, so.
Was that in your book? Like I know on a square, it dips down on the graph and then circles back up. And so it should hit the graph those 5 times. Have you graphed this one to see it?
I did. It was like really weird.
I'm going to graph it.
Okay, I'll do that too. Oh, I don't think I've ever hated anything more than I hate this class.
Oh, baby. Well, it obviously affects the shape of the graph. And what I say, usually on an even one, it's what I call kissing the graph because it touches as it comes back up.
Uh-huh.
And what is that graph? What does that graph look like? You describe it to me.
Like insanely ugly.
Okay.
Like I really don't know how to describe it. It kind of, did I even graph that right? I feel like I didn't graph it right. It's that bad.
Okay, 2x, and then it's raised to the 5th.
Is yours wildly ugly?
Well,
2x plus 5 to the 5th,
and then x plus
like
4 Oh, yeah, it's wildly ugly already.
It's really bad.
Squared. And then x minus 1. Okay. Yeah, it's wildly ugly. Okay. For the ones that make the most sense to me. All right. This one here is going to kiss the graph. You've got it's going to be a -4, and it's got a multiplicity of 2, and then we've also got a +1, and it's basically it's just going to cross the x-axis there when it's a multiplicity of 1. This is going to what I don't know if she'll appreciate this, but touch or kiss the graph and turn back up, because multiplicities change the shape of the graph. This is going to touch the x-axis and go straight back up. And an odd multiplicity is going to give it a bend like that.
Right. I just
Almost like it's touching it multiple times, but it's not really, and then curved down. But I don't know how to describe that.
I just said it curves. I don't even know. She literally didn't go over this a single time, so.
Okay.
So I don't really know like what she's looking for, you know.
Okay. I'm trying to find something where it's odd multiplicities, but they always like run along the x-axis kind of right there and then turn. So you did say turn?
I just said it curves. I don't know.
Turn, curves. Okay, sounds good to me.
Okay.
So this we're going to take out a 3x cubed out of this. It's going to leave us with x squared plus 4x plus 4. So that's going to be x plus 2 squared. That's what this is. Okay?
Okay.
Right here.
Okay.
So we've got a 0 as that, and it has a multiplicity of 1. And then we've got a -2 with a multiplicity of 2, and that's an easy one. It's going to touch the x-axis and turn back around. It touches and goes back up, where some people actually calling it kissing the x-axis and going back up. And this means it's just going to cross at 0.
1 second, Miss Spark.
Okay. Do you...
Okay, I'm back. Sorry.
No problem. Do you need to go, baby?
Soon, but I'm just kind of stalling as long as I can.
Oh, okay.
Try and understand.
I feel like you've got the long division thing, right? I went ahead and did it just so you would know the
I
answer.
messed up on one part of it because I tried to work that one out, so we love that. How did you get it to be? Wait. Oh, I see.
Oh, you know what? You didn't mess up. I did. I was like, that should have a remainder. I didn't have a placeholder.
Oh.
We're missing a 2. We're missing an x squared.
Mm-hmm.
And every division problem I did earlier, I always checked for my placeholder. And this one with you, I didn't.
Oh, no, you're fine.
-1 and 3. Did you put your placeholder in? Did you remember? You go, girl.
Thanks.
Did you get the same answer then? Did I get the same answer as you this time?
I got plus 5x minus 9 at the end, but I probably did something wrong. I feel like I did.
Let's see. I got -5 here.
Yeah,
-5 times 1 is -5. Then -6. Then -6 times 1 is -6. And 3 plus -6 is the -3.
Wait, what? Okay, hold on. Let me
Well,
just.
you're combining 3 and -6. So you take the difference and give the sign of the higher.
-3 and -6 is. Oh,
I don't have a -3.
it's written right there. Like 3 and minus 6 is -3. That's what I'm talking about. Like at the end.
Oh, okay.
Yeah.
You didn't get that?
No, I did.
Okay.
Hold. I think I know where I messed up. Hold on. Yeah, there we go. I figured it out. We're good.
Okay.
I just got one of my signs messed up.
Yeah, is this all on a test tomorrow?
No, the test is Wednesday, so
But this is all due tomorrow.
yes.
Okay.
So yeah. And I don't know whether or not she's grading for accuracy or for what. So
All right. Well, I was going to say,
I emailed you one more because there was like one page or something I left out just for you to kind of see what all we were assigned because there's 2 separate packets
okay.
that are both due tomorrow, which really does not make sense to me, but it's fine.
Okay. And I know you've got that other work that you've got to do too, right?
I have to do lit when I get home because I had beta club today. We had to do service from 1 to 3. So.
Okay. And okay, so the pictures that you sent me earlier though, like this picture here, let me pull it back up. This picture is part of the other one that you and I were working on. Is that correct?
Yes, I kind of mixed up both the worksheets, but like it could practically be one big worksheet, I guess.
Okay, so
And then I sent another. Yeah.
and then this is a separate one, correct?
Yes.
And and then this is the back page of that one?
The back page of one of them.
Okay.
I think is that the one we just did?
Yes.
Uh-huh.
That one's done.
Yes. So, yeah.
So at least one of them, one page is done.
Yeah,
And then
one
we
page.
almost got the first page done of that other one, right?
I think so.
This one?
I already had the front few pages done with that one. We got the other one done. There's one more left, numbers 4, 5, and 6.
Okay. And those are the ones that I'm gonna work on.
Okay. You could like just do one of them or 2 or however many. And then there's a whole other packet that like we just now started on. That has 1, 2, 3, 4 more pages. So I have 5 total pages.
Okay.
So I knocked out a solid half of it earlier.
Okay, you just sent me another one and it starts with number 8. Is that correct?
Um,
8, 9.
let's see.
Yes. Factor theorem, remainder theorem, all of those.
Yes, I sent you those two. Those two, and then the one that starts with 1, 2, 3, review 4, 1, graph power and polynomial functions. I think I sent you that one.
Okay.
The
Yes.
one that says due Friday or something.
Yes.
Okay. There's that. So those are the pages that I have left.
Okay.
Yeah. Loads of fun.
Was some of this assigned Monday?
No.
It was all assigned Wednesday?
Yep.
Oh.
Yeah, I know. She gave us the class period to work on one, but no one knocked out the whole thing. I just got a solid half of it done. My group did. And then we still had like 1.5 left to do. And they're not easy either, so.
Yeah. Okay. Oh, okay.
Yeah. You really don't have to do all of it. I might just wing it.
Well, I'll definitely see what I can get done. That
Okay.
yeah. I'll just see what I can get done because I was thinking that maybe some of it came from Monday
Uh-uh.
when maybe, you could ask for that, because I gave my volleyball girls a little grace, you know? And so like there was a quiz on Wednesday, but the ones that had volleyball didn't have to take it on Wednesday. They're actually taking it tomorrow.
Gotcha.
But I was just trying to be like, well, maybe you could just remind her that because I think the coach or somebody emailed or Miss Marcia or I mean Miss Robbins.
Uh-huh.
So I don't know, but if it was all Wednesday, I don't know what I can do for for you.
Yeah, I really don't think there's much. It's just today isn't the most practical because we have all this. We have lots of homework from other classes. I have homework from Tuesday too, since I had volleyball, and I had beta club, and I had practice. So
Yeah.
yeah,
Oh, buddy.
it's been loaded.
Yeah. Well, I'll be praying for you, and I'll see what I can get done. Okay, Angel.
Yeah, I really appreciate that.
No worries.
Thank you so much for your time as always.
No problem. Praying for you. Love you.
I love you too. I appreciate it.
Yeah. Take care, baby.
Okay, you too. Bye.
Bye.